Welcome back to the System Design series. And today we will be going through the System Design Methodology quiz. The idea is to test and recap the system design concepts that we have learned so far. Ready, set, go. Question number 1. What are design goals? A. Describes the important system qualities. B. Defines the values against which options are evaluated. C. Portability, reliability, scalability, etc. are examples of design goals. D. All the above. So if I think through, option A looks correct to me because design goals are nothing but the important system qualities. Likewise, option B, we define design goals as the values against which the options are evaluated. So there are choices that we have to make. Option C definitely looks good as well. Portability, reliability are examples of design goals. So I would go with D, as all of these looks correct. Great, we got that one. Let's move to the next one. Which of the following questions implies scalability? Option A, what should be the throughput rate for our system? Because it's talking about the throughput rate, and throughput rate normally is a characteristic of performance. Option B, should a system successfully work 100% of the time? This one seems to be more about availability, as it's talking if the system is available 100% of the time. Option C, how easily can we adjust our system as the number of users grows? This looks like, this is more like a scalability question because we are trying to say how would a system scale if the number of users go up or if the traffic that goes up. All of the above, option D. So definitely we said that A is not the one, B is not the one, so we can't choose all. So we'll go with option C, which is how easily can a system adjust, and I think that reflects scalability. Cool. Let's move on to the next one. Question number 3. Which of the following is true about system decomposition? Okay. Option A is about decomposing the overall system in manageable parts. That seems pretty right because in system decomposition, we're trying to break down the system into smaller parts and we want to make sure that those subparts or subsystems are manageable. Let's look at the next one. Option B uses the principle of partitioning and interfaces for decomposition. I think we know that partitioning and interfaces are concepts, but they're not tied to decomposition. They're more associated with the services where we have the concept of partitioning and interfaces. Okay, let's look at the next one. Option C, system decomposition is not needed for large system. This definitely is not correct because no matter what the scale of system is, you need to decompose your system into smaller parts. And more importantly, if we're talking about large scale system, you definitely need to do system decomposition. None of the above. We'll go with option A because that seems to be correct, and system decomposition is all about decomposing system in manageable parts. Let's see. Cool, we got that. Let's move on to the next one. Question 4. Which strategy do we use during system decomposition? Option A, plug and play. I don't think we covered plug and play. This kind of seems a little bit odd. Option B, bottoms up. Bottoms up normally means we start from the bottom and go to the top. In other words, we build the lower level components first and then the higher level components and so on. It's like going from the leaf of the trees back to the root. That doesn't seem right either. Divide and conquer. That seems like a good fit. We want to make a larger system, so we want to break down the system into smaller subsystems, and I think we want to use the divide and conquer strategy to be able to break the big system into smaller parts. None of the above. option D. So I think with those arguments, let's go with option C, divide and conquer. Got it. Let's move on to the next one. Question 5. What are the two ways of constructing software design? Let's see what the choices are. Option A. Make it so simple that there are no obvious deficiencies. Yeah, I think I remember that one. Option B. Make it so complicated that there are no obvious deficiencies. So this one also seems correct. You can make a system such that all the deficiencies are not there anymore, but while doing so, the system becomes complicated. Option C, none of the above. And option D, both of the above. So I think we should go with both of the above, option D. Cool. Let's go to the next one. Question number 6. Which of the following is true about KISS? Okay, yeah, I think we remember KISS. Option A, KISS, keep it simple, stupid. That looks correct as the acronym for KISS. Option B states design and or system should be as simple as possible. I believe that's true because the whole idea of the KISS is to keep it simple and stupid. Option C guarantees the greatest level of user acceptance and interaction. That is also correct because once we have simplicity in a design, that means users can engage more and interact with the system much easier. And option D, all of the above. So I think we should go with option D, all of the above. Let's move on to the next one. Question number 7. Which of the following is not true about software models? Okay. Option A, UML can be used to express software design models. This definitely is true. So we can express software design models using UMLs. Option B, software models convey low-level details of a system. This does not look to be true because we use software models as a way of abstraction, and normally they will represent information or structure at a high level rather than detail. So let's look at the other options and we'll come back to this one. Option number C, express a software design using abstract language. Yes, I think that's correct because UML is used for representation and UML can use the abstract language in order to describe the model. Option D, express a software design using pictures. Yeah, I think this is correct. UML is all about pictorial representation as well. So with this one, I think we should go with option B. Definitely this is not correct. Fantastic. Let's move on to the next one. Question number 8. Which of the following is true about software models? Option A, functional model describes the internal behavior of a system. Functional model describes the internal behavior of a system. No, the functional model doesn't do that. Let's look at the option B. Object model describes the functions of a system. Again, I think object model does not describe the functions. That's the functional model. And I think object model describes the structure and not the internal behavior, which should be the dynamic model. Let's look at the option C. Dynamic model describes the structural system. No, it does not. Option D, none of them. So I think I'll go with option D, none of them. Got it. Let's move on to the next one. Question number 9. Which of the following is true about object model? Option A, object model does not define association between objects. Object model is all about the property structures, function, and association. So definitely this is not correct. Object model describes the actors involved in the system. I believe this one is not correct because the actors involved in the system is from the functional model, not from the object model. Option C, object model can be described using use case diagram. This is not correct because use cases are used to describe functional model. And option D, none of them. So which of the following is not true? So I think none of them is true. So I'll go with option D. Cool. Let's move on to the next one. Question number 10. Which of the following is true about the dynamic model? Let's see. Option A. Dynamic model describes the internal behavior of the system. Yes, dynamic model talks about the internal behavior and how the objects collaborate with each other. But before we choose that, let's look at the other options. Option B. Dynamic model can be described using sequence or state diagrams. That is correct. Yes, these are the two different ways we can describe the dynamic model, which is the sequence and state diagrams. Option C. Dynamic model describes the external behavior of the system. So this definitely seems contradictory to the very first one, which talks about internal behavior, and this one talks about external behavior, and we already said the internal behavior is what the dynamic model describes, so this cannot be true. Cool. Okay, so option D, both A and B. So based on what we discussed, yeah, option A and option B are correct. So I'll go with option D. Fantastic. That concludes our quiz time video for the software development methodology. I hope that was useful and you got to learn and recap those concepts. See you next time.